Problem solving with trig. They've given us one piece of information, and we need to find the perimeter of this octagon. So this object has 8 sides, all of equal length. Okay? Hence an octagon. They've also told us that from the center, let's do something different here. From the center of this octagon to a corner is 15.8 centimeters. Okay? So this is 15 centimeters. They want us to find the perimeter of this. In other words, we need to find out the length of all 8 sides and add them together. Perimeter is adding all of the sides up. There's a couple of things we can figure out from here. Since the middle to one corner is 15.8, we can essentially recreate that from the middle to every single corner. Okay? That doesn't look like I'm starting at the center, but I'm doing my best here.
Can you draw a diagram?
That's actually amazing. So, these sides we have in here, what is similar about all of these sides? Think of it like a circle almost. They all start from the middle and go to the corner, so what's going to be similar between them all?
They're all going to have 15.8 centimeters length.
That's right. Every single one of these sides is going to be the same length. Okay? With that being said, we're going to isolate this into one triangle. Okay? So we're going to focus on just one triangle. We'll recreate it on the side here. Okay? We'll call that one of the triangles. We know that the 2 side lengths are going to be the same.
15.8.
Okay? So what type of triangle do we have here?
Scaly.
Isosceles. Good. Has 2 sides that are the same length, and the 2 lengths are 15.8 centimeters. Both of them are. Okay? We have no information about the angles. Okay? This is where you guys need to think back to maybe grade 8. Technically, if I go all the way around, adding all of the angles of these triangles, that's right, it's going to be 360 degrees. Very good. So we got to take this circle, and because there are 8 triangles making up this circle in the middle, we need to divide them equally. All of those angles are going to be the exact same, so we'll be dividing this by 8. 360 divided by 8. Anyone know?
45.
Good. 45 degrees. So in other words, the top of this triangle is 45 degrees. Now, we're still kind of missing some information. I do want to make this a little simpler. How can I find out the other angles very quickly? Anything special about those 2 angles, Trice? That's right. These, because this is an isosceles triangle, both of these angles here are going to be the exact same. Okay? That's right. Because the side lengths are the same, so we can, one we'll call A, one we'll call B, but we know that the angle is A and B, so angle A is equal to angle B. So, since a triangle has to add up to 180 degrees,
180 minus 45.
We're going to subtract our 45, which is going to give us what?
X equals divided by 2.
Well, let's go here. 135. And then that divided by 2 will give us 65? No.
65.
No, I think it's what?
67.5.
67.5 degrees. Okay? So, those 2 angles are 67.5 degrees. So, let's remake this triangle one more time with all of our information. We have 15.8, 15.8. This is 45 degrees. And this is 67.5 degrees. And this is 67.5 degrees. Now, in order to actually solve this question, did I need to find out those other 2 angles?
No.
I had this side, and this angle, and the goal is to find what?
Base.
The base. The goal was to find the base, the length of the base, because we're trying to find the perimeter. Let's say I hadn't found those 2 angles. What information, or of this information, what formula could I put it in to solve that side? Sine law? Who says sine law? And who says cosine? And who says tan? Right, so we have options. Sine law.
It can't be tan because it's not a right angle triangle.
Good. Okay. Definitely can't be tan. Anything from SOHCAHTOA. Sine law. What do we need to have in order to solve the sine law?
One complete side and 2 angles. Yeah, 2 angles. I mean, 1 angle, 1 side, and a side or an angle. 1 angle, 2 sides.
We can have 2 angles, 1 side. We can have 2 sides, 1 angle. But there's something specific about that information. Has to be set up.
One has to be a complete angle.
What do you mean by complete?
You have to have an angle and
An
side.
angle that are crossing
That are opposite from each other. That's what's extremely important. So let's say we had not found these, and we're just working with this here. If I hadn't had this angle or this side, I can't actually set up sine law because we don't have a complete ratio. You need to have an opposite angle and side. Now, since we did find these angles, we could definitely use sine law, or just using these three pieces of information, we could have used cosine law. Okay, so what we're going to do is we'll actually try to go through both at the same time and see how similar our answers would be. Because we're going to do rounding, they'll be a little bit different, but we should be relatively close in our answers. So, we're going to split it right down the middle. And we'll try to do both at the same time. I'm going to need your help with calculators here, guys. So, we have our sine law, and we have our cosine law. You can use either to figure out this information. With sine law, remember we're trying to find a side. And remember I told you the sine law can be written with the angles on top or the sides on top. It doesn't matter. But it is easiest to use what we're looking for on top. So what are we looking for?
Side length.
A side. So how should I set up this sine law formula?
Angles on the bottom.
Okay. So tell me the formula. What should it read?
Sorry, I can't see what the angle is. 15.8.
Oh, just give me the formula without the...
Oh, B over sine B.
Okay.
Sorry, A. Yeah.
Yeah.
And then A over sine A. And
Good.
C over sine.
So, Andrew could have set it up with the angles on top, but he chose to put them on the bottom because we're looking for a side. Whatever our unknown is, it's usually easiest if we have that on the top of the ratio or the fraction. Okay? And our cosine law. Remember, I got to rename a triangle for cosine law because the way we've learned it is just through one formula. What was that formula?
A squared minus A squared plus B squared.
We don't use it with A. Okay.
C squared, A squared minus plus B squared minus C squared.
Good. Good. I was listening to Andre there. He had it. Okay, so we have this information. We're going to name this triangle. I want to name this triangle in one shot so that it's useful for cosine law and useful for sine law. So, there's one side and angle I need to be very specific with. We're naming this triangle. What are they? Does anyone know?
What's the question?
So, I'm going to name this triangle ABC. And according to our cosine law, remember that's the one that's going to be important, I have to call one side a specific letter. Does anyone know what side and why?
45.
What do I need to call the 45?
C.
And why do I want to call this C?
Because we're looking for the base of the side C.
Okay, so that makes that side C. And what formula does that help us with?
Cosine.
That's right. We're focusing on the C. Okay. The A and B are not as important, and with sine law we can really name anything else, anything we like. So we'll call this A, and we'll call this B and B. Good. So you've set this up. You can name a triangle any way you like. We set it up specifically to help us. So we'll plug in our information. Our A was 15.8, and the angle was sine 67.5. Right? So there's a full ratio. B was the exact same thing. Okay, which makes sense. Hence why both ratios are the same. They are obviously the same thing here. And then C is what we're looking for. We're looking for side C. What's the angle? Anyone remember? 45. Good. Now, I don't need all three ratios in order to solve this.
One complete and the one you take back is incomplete.
That's right. Well, we actually have two complete. And they're both the exact same, so it really doesn't matter. I'm just going to drop off the A's. Okay? So we're just focusing on two ratios when doing sine law. So we have 15.8 is equal to sine 67.5, okay, which is equal to C divided by sine 45. If I want to isolate C,
Multiply by sine 6. Multiply that by sine 45.
multiply which side?
The
Right
right
side by sine 45.
Just the right side?
Both sides.
Both sides. Okay? I know we're used to saying that we just multiply it in the other side, but technically what we're really doing is multiplying both sides in an equation by the same thing. That's what's called balancing an equation. Okay? So we technically multiply both sides by sine 45. Now what happens on the right side of the equation?
Cancel out the...
Yeah, they create a 1. We usually call it canceling out. So we're left with just c. So essentially, once we get to this point, c is equal to just some numbers we need to put into a calculator here. 15.8 multiplied by sine 45. Right? When we multiply, it always goes on the top of a fraction. Okay? And all of that is divided by sine 67.5. Anyone want to help me out?
Sure, man.
Thanks. What is it? 12 didn't sound right? Someone said 12. Can anyone confirm this? Yeah? Let's check with our cosine law. That'll be a way to tell if we're relatively accurate, okay? So, we've discovered that c is 12. We still got to find the perimeter, but let's check with our cosine law. We're still looking for side c, so we have c squared is equal to side A is 15.8 squared plus side B is 15.8 squared minus 2 times. Now, because both are 15.8, I don't want to confuse you, but I'm just going to square it just so I have room. Do you guys understand that idea?
Yeah.
A and B are both 15.8, so it's the same as writing 15.8 squared. I wrote it just so I'd have room here, okay? And cos 45 is the opposite of side C. So we're going to work through this. Anyone got 15.8 squared for me, or I can bring it up?
249.64.
249.64. Great. So 249.64. And I'm going to say times 2. Why am I going to say times 2?
Because you're adding them to each other.
Yeah, because these are the exact same thing. So adding them together is the same as multiplying by 2, right? And look at this. Ends up being the exact same thing over here. 2 times, and we know 15.8 squared, we just did that, is 249.64. I really only had to use a calculator once here so far. Cos 45. What is 249.64 times 2?
499.28.
Read off my computer.
You guys are the best. There you go. Cos 45. Now, according to BEDMAS, what would be my next step? Multiply what?
Negative 499.28.
That's right. We do not do that subtraction. That subtraction, if you were to make this mistake and do the subtraction, you would get what number?
0.
0. And then what you're saying is side C is 0 in the end, which we know doesn't make any sense. Okay? We have to follow BEDMAS, so we have to multiply this first. 499.28 times cos 45.
Negative 353.04.
All right, let's take your word. What did you say? Oops. Give me 1 sec. Negative 353. Perfect. Okay. We then have to subtract 499 with that value. We should get around 144, I think, if we're right. What is it? 146? Point something?
146.24.
24. Great. And then it still says c squared. So in order to get c by itself, what must I do to both sides? That's right. We must square root both sides. So we're going to get c is equal to what?
Hold on.
And this
12.09.
12.09, which is approximately 12. So it looks like we've done both of these correct, all right? I'm sure this one probably had a decimal to it. We just didn't go through it. So what was the original question asking us? Does anyone remember?
Perimeter.
Perimeter, how many sides were there?
8.
So let's go with the 12.09.
Times it by 8. There's 8.
Just multiply by 8 to find the perimeter of our octagon. Okay, perimeter of O. So perimeter of our octagon.
96.72.
72. Sounds good to me. Give them a round of applause. Great job.